Hello, I'm Max Briggs, the Program Executive for NASA iTech. I'd like to thank you all for taking the time to watch our 2021 Cycle 1 Forum. For those not familiar with iTech, we are a commercialization-focused pitch competition searching for innovators and investors that may not consider NASA or government as their primary customer. This gives entrepreneurs a great opportunity to engage with NASA and investors to determine if the ideas that they are targeting for the private sector could also be relevant to NASA missions and NASA strategic goals. The iTech program is designed with many features that government programs are not known for, including low barrier to entry, an accessible and less prescriptive solicitation, and a more personal feel, as iTech companies not only interact directly with NASA chief technologists and investors during the competition, but also receive personalized coaching with the iTech team in preparation for today's event. During today's program, you will hear 9 10-minute pitches from a distinguished roster of companies, including Blue Space AI, Full Cycle Bioplastics, Howe Industries, Mito Material Solutions, Osteodx, Parasanti, Predictive Care, Skylabs, and United Aircraft Technologies. For this event, we are experimenting with a new format in which the live stream contains only the company pitches and the announcement of the winners. However, our distinguished panel of judges have also engaged the companies in question and answer sessions, which are also available for viewing online. Prior to the company pitches, you will also hear from one of our featured speakers, Jason Kessler, the program executive for NASA's SBIR program. And prior to the announcement of the winners, you will hear from Dr. Claire Martin of Astroscale, a company focused on sustainability in space. Before we get to our pitches, I would like to use the opportunity to let the audience know a little bit more about NASA's evolving entrepreneurial engagement strategy, which I hope will keep NASA on the cutting edge of innovation far into the future.
What's the first thing you think when someone says NASA? Neil Armstrong touching down on the moon? The Perseverance rover making an impossible landing on Mars? Pictures of Earth taken from space? Pictures of distant galaxies taken from Hubble? You're not alone. Those are truly inspiring accomplishments, and they deserve to be celebrated. Because NASA tackles some of the hardest problems in the universe, many people immediately associate NASA with innovation. But as a NASA insider, when I think of NASA, I think of something else: risk management. How can we make sure a billion-dollar mission goes off without a hitch? Typically, we take high TRL technologies and test them in some of the most challenging environments possible until we are certain that they can withstand anything they're going to encounter. There's good reason for this, but the drive towards reliability is not always aligned with the spirit of innovation or the development of disruptive technologies. With so much focus put on mission assurance, we oftentimes need help from the private sector to maintain our edge in innovation.
As the countdown to Mars continues, the perseverance of humanity launching the next.
And this isn't the first time we've been here. Consider the historical example of NACA, the National Advisory Committee on Aeronautics. NACA was established in 1915 to turn crazy aeronautical ideas into usable technology. Usable at that time usually meant usable by the US government. In the early days of NACA, there was no real commercial aviation market serving passengers. However, fairly rapidly, the technology progressed and passenger air travel became not only viable, but profitable, and private companies began driving innovation in aviation. As this happened, NACA's role in the innovation ecosystem had to evolve. For those that don't know, NACA was absorbed by NASA when it was formed in 1958, and NACA's aeronautics legacy lives on to this day through NASA's Aeronautics Research Mission Directorate, which now focuses primarily on stimulating emerging commercial aeronautics markets such as advanced air mobility, unmanned aerial systems, and low-boom supersonic passenger aircraft. The NACA transition from innovating to serve a direct government goal to innovating to stimulate emerging markets provides a useful analogy for the evolution of NASA's role in emerging space markets. Tasks that were once too risky and too expensive for anyone besides large governments can now be accomplished by private companies, and sometimes at a fraction of the cost. Consider that only 10 years ago, NASA was flying shuttle missions to resupply the space station at a total program cost of about $1.6 billion per launch. Today, NASA purchases rides to the ISS from SpaceX at a cost of roughly $400 million per launch. This clearly has a direct benefit to NASA, but one could argue that the biggest impact of this new capability is making access to space more affordable for a host of commercial entities. As launch costs come down, more and more space-based business models become viable, making space an exciting host for several emerging commercial markets. If the United States wants to continue to lead in space, it is clear that we will not only need to support challenging government projects like getting astronauts back to the moon and onto Mars, we will also need to lead the commercialization of space. Just as most people in 1915 likely didn't comprehend how much commercial air travel would change the world in the coming decade, today, all except the most visionary among us probably have no idea how the emerging space economy will affect our lives in the coming decades. So the question for NASA is, where exactly do we fit in all of this? My personal hope is that NASA continues to be a mission-driven organization focused primarily on expanding human reach and knowledge of the universe by taking on the most challenging missions in the world, the solar system, and the universe, all while inspiring generations of thinkers and dreamers for decades to come. To accomplish these goals, we will likely always need to engage traditional space companies with highly focused technology delivering high-performance, high-reliability products to low-volume customers like NASA. However, as space continues to evolve from a domain dominated by governments to a domain in which governments are just one of many users, NASA must evolve and diversify, stimulating and shaping these markets by engaging non-traditional space companies and leveraging private sector investment. In order to do this, we need to evolve programmatically. NASA must develop government programs that are fast, agile, and human. We must figure out how to effectively complement and leverage private sector investment.
Splashdown.
iTech's role is to shine a light on non-traditional space companies that either directly contribute to NASA-relevant commercial markets or have the opportunity to spin commercial technology into a NASA application. For example, one iTech alumnus, Momentus, who recently went public with a valuation of more than $1 billion, is looking to offer space tug services primarily to commercial satellite companies. Although NASA is not the intended primary customer for Momentus, the advancement of space tug capabilities and competition among last-mile delivery platforms could improve commercial capabilities in low Earth orbit and make LEO more accessible for a host of customers, including NASA. Entrepreneurial engagement programs like iTech are a good first step to leveraging the power of private sector innovation, providing a forum with many of the features that are expected in the entrepreneurial world, such as speed, flexibility, low barrier to entry, networking, and investor engagement. As we go forward, NASA will continue to examine its existing programs to determine how to make them more friendly for entrepreneurs and agile, growth-oriented, and commercialization-focused companies. Where we cannot accomplish these goals with our existing programs, we will continue to innovate new programs to effectively leverage the private sector to contribute to NASA missions and to stimulate emerging commercial space markets that are aligned with NASA's strategic goals and congressional mandates.
Thank you all for participating today. I think the interaction between the investors, the innovators, and the NASA technologists is really what differentiates this program from many of the others offered in the government and possibly the other ones that are offered in the private sector as well. And so I really appreciate you all taking the time to participate in the events and really make them successful. And now, without further ado, I'd like to move on to our company pitches.
And first up, Osteodx.
Hi, I'm Gary Wakeford, Chief Executive Officer of Osteodx Incorporated, and we're going to go on a journey together today to understand a little bit more about the cortical bone mechanics technology developed at The Ohio University in Athens. Do you realize that mankind is quickly approaching a time in our evolution when never again will every human being be on the planet Earth at the same time? With the International Space Station and with the progress that has been made in reaching Mars, it is very likely that there will always be a certain number of humans in space. It is also very likely that this number will only continue to increase over time. Did you also know that NASA has already shown that every single person that goes to space experiences bone loss? The longer a person is in space, the greater the magnitude of loss in bone density. This is not only the potential to adversely impact the amount of time they can spend on a mission, but it also holds the potential to predispose them to the early onset of osteoporosis and other bone-based deficiencies. This is a dilemma that will need to be effectively addressed if man is ever to spend significant amounts of time in space. The problems caused by osteoporosis, osteopenia, and other bone diseases is also a huge problem today on planet Earth. Just in the U.S. alone, there are 2.3 million fragility fractures of bone that is currently costing the U.S. healthcare system $19 billion. Yes, that is billion with a B. A fragility fracture is defined as a fracture that results from mechanical forces that would not ordinarily result in fracture. This basically means that the bone should not have fractured, but it did due to the presence of a weakened bone state. This is a simple equation to understand. As people age, there's a higher incidence of osteoporosis. More osteoporosis means more fractures. This malady is not unique to the United States. According to the International Osteoporosis Foundation, globally there are 9 million fragility fractures each year at a cost of $75 billion. This problem is further compounded by the fact that the current standard of care, which is dual X-ray absorptiometry, or DEXA, which measures bone mineral density, is a very poor predictor of fracture. Bottom line is that bone mineral density does not equal bone strength. Leading physicians in this space have quoted as saying, the ability of DEXA to accurately predict a patient's fracture risk is less than that of a coin flip. The current rates of both false positives and false negatives exceed 80%. The end result of this is that we have millions of people receiving treatment who probably don't need it, and many more millions in need of treatment who don't qualify for it based on their DEXA score. The cortical bone mechanics technology was developed at Ohio University in Athens, Ohio. The company has a strong working relationship with the state support of the university's Innovation Center, the Technology Transfer Office, and the funding arm of Tech Growth, Ohio. So, we have a problem that is acknowledged by NASA, it's acknowledged by the U.S. government, and acknowledged by the U.S. healthcare system. So let's talk a little bit about the solution. And that solution is the cortical bone mechanics testing technology coming out of the Ohio University in Athens. It utilizes vibration analysis to measure the cortical bone stiffness of the ulna. And this is important because it does it radiation-free, it's non-invasive, it's painless, and it's very easy to administer. Initial proof of concept testing included the use of both artificial ulnas and cadaveric ulnas. When the cortical bone stiffness of the ulna, estimated by the CBMT technology, was compared with the scientific research gold standard of quasi-static mechanical testing, the data all fell along the same identity line with an accuracy determined to have an R-squared of 0.999. Further testing utilized quasi-static mechanical testing to demonstrate the correlation between cortical bone stiffness and cortical bone strength. This also provided an R-squared of 0.999. This clearly demonstrates that cortical bone stiffness equals cortical bone strength. Now, when reviewing the current methodologies used in the marketplace, DEXA is by far the dominant player in the current standard of care. The common Achilles heel of all the modalities used, however, is that to one degree or another, they all rely on bone mineral density measurements to predict fracture risk. Again, all of the science overwhelmingly demonstrates that bone mineral density is simply a poor predictor of fracture risk. We at Osteodx are confident that we can further refine the data that we measure to accurately identify a patient's risk of fragility fracture. This is the key to being able to intervene and prescribe treatment to heading off and preventing the fractures from ever occurring in the first place. The roadmap to successful commercialization of the CBMT technology follows a very straight and direct path. We will start first with the research use only market. We will then transition to the U.S. clinical market, and then we will transition to the global international market. Stage 1 involves initially selling the CBMT technology as a research use only device into the scientific and research community. Big pharma companies producing and conducting research on drugs designed for the treatment of osteoporosis also provide an avenue for sale as a research use only device. Sales of research use only devices do not require FDA approval to market. We will use this data to secure FDA approval and move into the U.S. clinical market. Step 2 will involve our entry into the U.S. clinical market as a Class 2 de novo medical device. We have completed an initial pre-submission with the FDA and are in the process of completing a second. The intent of the second pre-submission is to gain clarity on the specific testing the FDA will want to see in our formal application. It is our intent to submit our formal application to the FDA by July of 2022. This will now allow initial sales into the clinical market by late 2022 and early 2023. Stage then will be after securing FDA approval to market the technology in the U.S., we'll work with our regulatory partners to secure required approvals to market the product into Europe and beyond. Our path in supporting this roadmap to a successful commercialization includes the following. Number 1, through science, we will clearly demonstrate the higher accuracy of the data measured by the CBMT technology and also show the clinical value of the information provided. 2, we will complete a Phase 2 SBIR clinical study demonstrating the ability of the technology via a fracture discrimination study. 5 sites to begin in September of 2021, SBIR grant start date of June 1st, 2021. In conjunction with working with key opinion leaders in the bone research world, upon receiving FDA approval to market, we will secure a temporary CPT code as the technology is very unique. We also have what we believe are very reasonable sales projections that will align us to be a successful target acquisition by one of the key providers of DEXA. The Osteodx team has a very strong group of professionals, as is evidenced by the results to date. We have achieved much with little. We started with state and federal grants to validate the technology and did so very successfully. Our results were so impressive that we have been awarded a Phase 2 grant from the National Institutes of Health for $2 million. We have secured follow-on investments of $450,000 with a $1 million target. If you take a look at our team, our board chairman and our CEO have both successfully taken a product from initial conception to FDA approval and have achieved very successful exits. Board advisors with strong, successful grant writing experience and nationally recognized experts in bone research are part of our team. We are in the process of completing our seed round of funding where we have targeted a raise of $1 million. Our ask is the following. Osteodx is looking for additional investors in the $250,000 to $500,000 range, and we are also looking for an introduction to the NASA healthcare team. With a $75,000 average selling price and a 66% margin, this becomes a very attractive opportunity for a lot of people. We are also working on a second generation version of this technology with a much smaller footprint, which will make it more amenable to being placed in primary care physician offices. There has been a significant amount of activity in mergers and acquisitions in this particular space. We are confident we will become an attractive acquisition target. So our final ask of NASA is help us help you.
And next we'll continue on with United Aircraft Technologies.
We live in an age where most people have experienced flight. However, not many are aware of the time and money it takes to put a plane in the air. American Airlines, for example, owns over 200 Boeing 737s and spends tens of thousands of hours maintaining the 30 miles of wiring being held within. Wiring that is currently held in place by around 20,000 metallic clamps. But what if there was a better way? Imagine no longer wondering what's behind these soundproofing panels, doing wiring inspections in minutes instead of days, getting a prescription based on data and algorithms telling you what the problem is, how to fix it, and where it is located. Imagine the thousands of hours and millions of dollars that can be saved if a system existed that gave you the real-time status of the electrical wiring. My name is Eva Rising, and I am the CEO of United Aircraft Technologies, UAT. And we are reimagining electrical wiring management with our sensing clamp system that reduces weight, minimizes operational costs, and improves maintenance through augmented reality and artificial intelligence. How do we know? UAT was created based on the life experience of a US veteran, Darian, who was an aircraft electrician for the US military for over 14 years. Due to repetitive strain injuries from installing the metal clamps used in today's aircraft, Darian's career was ultimately cut short. Although he had lost his job and his home, Darian turned his hardship into hope and became an engineer to create the solution. With his technology and my experience as a successful entrepreneur with a prior exit, we created UAT. Together we lead a team of engineers and business professionals with backgrounds at Boeing, Lockheed Martin, the US Air Force, the US Navy, and even NASA. Our lead aerospace engineer, Gerardo, has over 30 years of experience working for IBM, GlobalFoundries. Our lead software engineer, Rocky, has worked on prior successful projects similar to this with Lockheed Martin and NASA. The team also consists of a group of retired military directors such as Valerie L. Muck from the US Air Force, Emily Harmon from the US Navy, and multiple officers from the US Army who guide us on our path towards commercialization. This age of aerospace innovation and revolution is leading to incredible achievements in engineering. However, this comes with increasingly complex electrical systems, and we must innovate the way we monitor and manage them. Equipment has been developed to minimize aircraft downtime and reduce operational costs of the biggest component in an aircraft, the airframe. However, not much monitoring, if any, exists for the second biggest component, the wiring. For that reason, UAT has reimagined electrical wiring management and created smart interconnecting clamps that can replace the inefficient clamps of today. UAT's patented interconnecting clamp system for aerospace wire harness management replaces the legacy metal design with a new ergonomic and considerably lighter resilient thermoplastic alternative. This is not just a clamp, but a smart clamping system with an embedded network of sensors that can map, monitor, and diagnose faults in the electrical system of any vehicle imaginable. It measures amperage, EMI, temperature, and other variables all wirelessly and without the need of batteries. You simply place the clamp, assign it its location, and you are ready to begin monitoring the electrical systems, thanks to our algorithms and preloaded thresholds. The smart clamp combined with our augmented reality monitoring system uses artificial intelligence to create a live digital twin of the entire electrical system. This digital twin guides the crew in localizing, diagnosing, and troubleshooting its electrical problem, thus improving fault diagnostics by over 150% and minimizing the reliance of visual inspection and risks of human error. Crews no longer need volumes of manuals and days of labor to troubleshoot electrical problems. UAT provides the status of the entire electrical wiring system in real time in the palm of your hand, reducing troubleshooting that takes days or weeks down to hours with a few simple steps. Our unique design also avoids additional metallic installation hardware, making our products 65% lighter than the current metal clamp. If you were to replace 15,000 to 30,000 of these clamps in an aircraft with ours, the total weight of a commercial aircraft that can be reduced is by over 600 pounds or 800 pounds or more from a spacecraft. Let's look in more detail on how our smart interconnecting clamp system can reduce weight in current spacecraft. A NASA launch costs an estimated $10,000 per pound of payload, and with 50,000 pounds of total payload, that one launch costs $500 million. Our clamps will remove 1,700 pounds from the total weight of the spacecraft, saving NASA $17 million per launch in weight alone. Keep in mind that these savings will be in addition to the hundreds of hours of maintenance and labor saved by our system's ability to see directly into the problem areas in the electrical system. This technology could also go beyond rockets with potential uses in the International Space Station. Currently, in the event of an electrical malfunction or during routine maintenance, our astronauts will be required to troubleshoot or monitor complex wiring bundles and electrical systems using up hours looking through manuals and navigating what's behind the panels. In a situation like this, our smart interconnecting clamp system in tandem with our augmented reality monitoring system will illustrate the map of the entire electrical wiring and integrate the hundreds of pages of information into a user-friendly representation. For example, in the case of a malfunction, it will be able to identify the fault, providing our astronauts with the additional time needed to address the malfunction and saving hours of their time so they can focus back on the main mission they went into space for. At UAT, we have strived to be the leader in both weight-saving capabilities of our clamps as well as the resilience of our materials, capable of surviving extreme environments, setting UAT's clamps above other thermoplastic and metallic fasteners currently available. We have also worked on being one of the best solutions for wiring troubleshooting and diagnostics. While currently a process called time domain reflectometry is used to detect impedance changes in electrical wiring, this process, however, requires the aircraft to be grounded, and it can't detect the exact location of a fault down to the wire. Unlike our smart clamps in tandem with our augmented reality monitoring system, which can provide live monitoring on the ground and in the air. The commercial opportunity for our clamp is substantial. As an example, let's revisit the 737. Pre-pandemic, Boeing made 52 737s per month, each having 20,000 fasteners and clamps. That's over 1 million units a month, just for one model in one market. Take into consideration the many applications of this technology in the electrical grid, all forms of ground transportation, watercraft, and even the potential market in spacecraft. Therefore, we estimate that UAT has a $16 billion market opportunity. We've also made substantial progress in our commercialization process. We work with multiple manufacturers such as Lockheed Martin, Bell Helicopters, and Boeing on their modernization projects such as the Future Vertical Lift, which is aiming to replace the current legacy aircraft with far superior and efficient rotorcraft, where UAT has the opportunity to be part of this growing fleet for decades to come. Due to our performance track record and results in a short period of time, we've already obtained over $1 million in contracts through the Future Vertical Lift initiative in the US Army, as well as through the US Air Force contracts. And we are on track to surpass it this year. Additionally, we've recently closed a $1.5 million round of funding coming from investors that were prior officers in aviation in the military and commercial sectors. We are set to launch our non-sensing model in 2021 and our sensing model in 2022, which is currently on a tier level 6. We understand the high quality performance necessary for aerospace, which is why we have tested it on the rigorous military specifications and have passed thus far. We've also established our manufacturing facility, which is ISO 9000 compliant and capable of producing up to 1 million units with space to grow. Currently, we're looking for collaborations so we can continue to apply our technology to the aerospace market and opportunities to showcase what we can do. Our mission is to create the modern standard of electrical wiring management and maintenance. Anywhere there is wiring, we plan to modernize it. Perhaps UAT can be the monitoring tool for future space hubs and settlements. Let us work together and reimagine electrical wiring management as we know it. See you there.
Next is Skylabs with the North Carolina School of Science and Mathematics.
Picture yourself exploring the frigid Arctic, or say in the midst of a freezing winter as you travel to work. How about just skiing down your favorite slope? In any case, you probably pictured wearing one of those puffy winter jackets. What if there was a jacket that was as thin as a windbreaker, but could keep you warm in even the most severe cold? An advanced aerogel that could accomplish such a feat could also have many other commercial applications. This is where we come in with EcoGel, a sustainable apparel insulator. Hi, my name is Prachiti Shakarkane, the CEO of Skylabs.
Hi, my name is Callista Holishak, the Chief Technology Officer of Skylabs.
Hi, my name is Suhani Ramchandra, the Chief Financial Officer at Skylabs.
Hello, I'm Rashika Ray Chaudhary, the Chief Operations Officer of Skylabs.
Drawing inspiration from NASA's game-changing aerogel technology, we are working on a carbon biopolymer aerogel derived from cellulosic fiber. EcoGel is naturally sourced. Its earthly derivation, coupled with a highly flexible, non-toxic, and water-resistant nature, make it an ideal candidate for applications in high-performance apparel. EcoGel also proves competitive in comparison to current apparel insulation. Current forms of apparel insulation include down and synthetic filler. Down filler loses its insulatory properties in wet conditions and when compressed. Down is derived from the feathers of geese and duck, which are plucked from the chests and lower backs of these animals while they are still alive. In comparison, synthetic filler, although more cost-effective and water-resistant, dries out easily and has lower compressibility, adding bulk. Patagonia and the North Face currently partner with Primaloft, a synthetic down manufacturing company, to use their insulatory material. Patagonia, the North Face, and Columbia have all attempted to use aerogels in the past for their jackets, although none have had significant success. In one attempt, it was found that the silica aerogel tended to flake out of the fiber blanket with movement, and also tended to suck out moisture upon contact, leading to the skin drying out. This meant that the material had to be encapsulated, which cut the breathability down to virtually zero.
As compared to Primaloft, EcoGel is able to provide significantly more insulatory capabilities with just 25 millimeters of thickness, while simultaneously maintaining breathability. Since EcoGel's production process is less energy intensive as compared to silica aerogels, the product will also enable viable production costs and market price. These high-performance apparel brands have displayed a significant emphasis on environmentally sourced products, with Patagonia's tagline being, "We're in business to save our home planet." Patagonia even pushed for Primaloft to adopt more environmentally conscious production methods before they would allow a partnership. With these values and a need for powerful insulation technology, we've identified high-performance clothing manufacturers as ideal customers for the sustainable EcoGel's market entry. We'll be looking to establish partnerships with these companies to incorporate EcoGel into their products. The high-performance company Oros has developed an aerogel insulator solar core, which, although effective, has limited economical landscape and is largely proprietary. We are looking to partner with this company to potentially fuse the best of our aerogel technologies and perform temperature testing. With environmental concerns at the forefront of our country, consumers are becoming increasingly environmentally conscious, seeking sustainably sourced apparel over cheaper, yet harmful alternatives. The high-performance apparel market, which is intended for athletic wear and protective gear, faces an increasing demand for transparency as to what materials it uses, which is what EcoGel will work to address. The high-performance apparel market was valued at $8.2 billion in 2020 and is expected to grow at a considerable rate of 9.6% between now and 2026, presenting a significant market opportunity for Skylabs' EcoGel. But EcoGel's insulatory capabilities span across several industries: aerospace, construction, and transportation. Rocket fuel tanks are kept at extremely low temperatures, and while materials like polyurethane foam are lightweight, they are coupled with ecological and health issues, as well as a lower insulatory power when compared to the aerogel. Respiratory sickness and skin and eye irritation from the physical exposure during the installation process, and the energy-intensive processes are outcomes of polyurethane. The presence of isocyanates carry highly reactive chemicals, increasing the toxicity of polyurethane. EcoGel's cellulosic structure enables a non-toxic and porous material, making it the ideal candidate for use in the rocket fuel tank.
But not only is EcoGel a powerful and flexible insulator, it also displays EMI shielding capabilities and flame retardancy, which is why the material is so applicable to the aerospace industry. While current aerospace companies purchase separate materials for insulation, EMI shielding, and flame retardancy, EcoGel supplies a solution with all these properties into one product, all at a competitive functionality. Unlike polyurethane foam, which has an unforgiving production process and requires on-site manufacturing, EcoGel can serve as an accessible insulation at an affordable price. Because of this, upon going to market, EcoGel will target startup aircraft manufacturers to partner with, as we see them in comparatively immediate need of an accessible, low-cost, and versatile aerogel solution like EcoGel. We've identified startups like Launcher, Ampere, Vico, Zunum Aero, Magni X, and Joby Aviation for this purpose. We see NASA benefiting from our unique product as it has a wide range of applications to meet their needs. EcoGel can be used on NASA's rovers, spacecrafts, space stations, and other facilities as a thermal insulator, EMI shield, and flame retardant, all while supporting the environment. Commonly employed silica aerogels are known to be extremely brittle, which is a significant point that EcoGel solves by incorporation of cellulosic fiber of greater tensile strength. In the future, EcoGel's thermal properties can potentially be used for planetary exploration. Recently, NASA's Perseverance successfully converted atmospheric carbon dioxide into breathable oxygen gas. The system used for this, MOXIE, contains a solid oxide electrolyzer, which operates at a high 800 degrees Celsius, requiring a strong thermal insulation system. While aerogels are already being used for this, they could be improved with EcoGel, which reduces overall costs compared to traditional silica aerogels that are currently used. Many of the aerogels currently on the market are in the form of silica and TMOS reagents, which even in small concentrations can cause lung lesions and even blindness if in contact with the eye in larger concentrations. As a result, the fabrication and testing of silica-based aerogels is limited for the need for caution in handling the toxic TMOS reagents.
Some other commonly used forms of insulation upon commercial aircrafts include fire protective insulation blankets or ceramic fiber fire blankets, as well as mica sheets. However, the mining of mica poses environmental risks and health concerns for miners, with repeated exposure to mica powder characteristic of causing lung scarring and irritation. The mining process is labor-intensive and often carried out by hand in developing countries such as India, where the workers are sparingly paid. Mica mining is also conducted illegally in some countries, heightening the risks for those involved and to the environment because of low regulation. As compared to this, EcoGel not only provides a safer alternative, but also displays significantly more insulatory properties coupled with EMI shielding and flame retardancy. We are a very early stage startup, conducting prototyping of aerogel at the North Carolina School of Science and Mathematics. Although we haven't been able to characterize our product's physical attributes yet, academic literature supports the idea of superior flexibility, flame retardance, and EMI shielding. We are here seeking strategic partners that can assist in this physical assessment. Having been able to complete the initial parts of EcoGel's production, more intensive labs and heating equipment will be required to complete the prototype. We will be reaching out to local universities such as Duke and NC State to scale prototyping in the coming months. We are requesting consultation and mentorship from a subject matter expert within chemical and material engineering to validate and expedite our production efforts. We're also looking to have discussions with NASA subject matter experts familiar with production of aerogels, as well as potential access to NASA testing facilities to test the material properties from our initial production run. While we are in the process of filing a provisional composition of matter patent, we are also looking for someone to help us develop an IP strategy. In the coming months, we are also looking to apply for SBIR and STTR programs funding to raise seed money.
Once brought to market, EcoGel would be one of the first commercially available biopolymer aerogels. Pioneering the future of environmentalism and technology, we at Skylabs are dedicated to advancing our materials both on Earth and beyond. We hope that you'll help us in pursuing this mission. Thank you.
And now I have the pleasure of introducing someone I've had a chance to work pretty closely with at NASA over the last several months and years, Jason Kessler. Jason Kessler is the program executive for NASA's SBIR, Small Business Innovative Research Program, and the Small Business Tech Transfer, STTR programs. Prior to joining the program in February of 2021, Jason served as a senior advisor to the Global Knowledge Initiative, where he created systems-focused learning experiences for clients in the developing world, targeting an increase in the use of science and technology to strengthen environmental and climate change programming. Prior to that, Jason spent nearly 15 years at NASA, serving most recently as a program executive in the Office of the Chief Technologist from 2013 to 2016, and as a deputy project director for server a unique partnership between NASA and the United States Agency for International Development, USAID, from 2010 to 2013. As an entrepreneur and consultant serving outside of government, he started several businesses himself. Jason is also the recipient of 2 NASA Exceptional Service Medals and a NASA Group Achievement Award, and recently published his first book in 2020 called Simple Acts Practices for a Broken World. Jason, thank you for agreeing to talk here today.
Thanks so much, Max. I'm grateful for the invitation. It has been a real pleasure getting to know you and love what you've been doing with the program. And I also want to congratulate all the finalists. As I looked through the list, there's a great representation. We have some younger teams, some teams with some older members. We have women and minority-led teams. We've got small teams and large teams. And I was reflecting what a fantastic representation of the country we have in this microcosm of the finalists. I do want to share a little bit about the SBIR and STTR programs because I think it may prove relevant, but I won't spend a whole lot of my time talking about that, as you can get information on that later. But basically, the SBIR and STTR programs were created to support the nation's small businesses, develop technologies for various agencies within the US government. And the reason why I wanted to at least mention it to you is because I think of it, and it really is non-dilutive cash that you could obtain to help you build out your idea. The program works in 3 phases. And we have 24 focus areas. So if you can find a focus area that aligns with your technology, you can submit a proposal through our solicitation, which opens up in early January, and compete for up to $125,000 for a 6-month period, which grows to $750K in our phase 2 period for two years. So you entrepreneurs can think about the SBIR, STTR funds as almost like a customer helping you build out your ideas. So enough about SBIR and STTR. Again, I'm happy to follow up and point you to any directions that might be useful as you continue on your journey. But I thought I'd take a step back because Max mentioned the 15 years, almost 15 years of service that I've had the privilege of giving to the country on behalf of the space program. And I go back to 1998. I was working in the office of the NASA administrator and found myself in Baikonur, Kazakhstan for the first element launch of the International Space Station. Hard to believe it's more than 20 years ago. And the ISS has been flying safely since then. What's great, I think, about looking back at that time is creating that now national laboratory has provided an opportunity for low Earth orbit launch services, as well as opportunities for folks to do research in that completely unique environment. And because I argue that there was an ISS, there was a need to explore commercial services to take goods, people up and back to space. So in 2006, NASA did that very thing. It created the COTS program, or the Commercial Orbital Transportation Services Program, to incentivize and award monies to companies to provide services where NASA would no longer own the vehicles, but rather buy the services from the providers. A little bit later on in 2010, the Commercial Crew Program is developed, recognizing that services for supplies would not be sufficient. We were recognizing that the space shuttle was going to be coming to the end of its career. So Commercial Crew gets started in 2010, and then July 21, 2011, the Atlantis Space Shuttle Atlantis lands and closes that incredible 30-year chapter in shuttle history. Next up was October 2012. We have commercial resupply services contracts. So we're now actually paying to supply the space station through private companies. And shortly thereafter, we closed down that commercial orbital transportation services program because it was so wildly successful. In parallel, as we're developing the commercial crew, you might recall May of last year, May 30th, in fact, astronauts were launched from US soil for the first time since July of 2011. And the reason why I took you on that journey is, as I said, I've been at NASA for about 15 years. I've been in and out of NASA. And when I left the first time, I left in 2001. I ended up going to business school to get my MBA focused in entrepreneurship. And there weren't that many options in the space sector. Aerospace more so, because aeronautics was had a very vibrant terrestrial marketplace. But for low Earth orbit and space exploration, it was really limited. There were a handful of primes. But as we journeyed through this development process and NASA's rethinking of how it actually delivers on its mission, and started to recognize that we could actually not have to own vehicles, but rather buy the services for those vehicles, we really see this burgeoning space economy. When I look around compared to 20 years ago, it's just incredible what is now possible. And as Max mentioned, I've spent a bunch of my time, most recently when I was outside of government, focused on climate and Earth system science. And so I think I'll give you a couple of specifics around how that sector has grown. So if we flash back 1999, we have pretty limited options for launch and observation. Space Shuttle was flying. It was $1.5 billion to launch, roughly $55,000 per kilogram. Also in 1999, first commercial observation satellite, high resolution, the Iconos. It weighed in at 800 kilograms and had a 3.2 meter multispectral resolution. That was groundbreaking. I don't know, those of you that might remember back, the Washington Post had on its front page an image of the monument. It was really groundbreaking to think that the stuff that had been in the spy satellite world was now out and available for the commercial marketplace. And NASA was operating a number of satellites collecting data on the Earth. And what we were doing is we were placing that data into these data centers that were distributed across the country. Huge amounts of data going into facilities made it difficult to access, made it difficult to play with, and there were certain languages, made it hard for people that weren't familiar with that data actually use it. So it was expensive to get to space, very limited options. We had a beast of a commercial satellite, 800 kilograms, and siloed data. Fast forward to today, and what I like to think of as this Earth observation renaissance. We're now flying the Falcon 9. It's only $62 million to launch, coming in at $2,700 per kilogram. Expanding the market, we have Rocket Lab, which is dedicated to small sat launch capability. Add to that, Astra, also seeking the small sat marketplace, and has its legacy within SBIR. So suddenly you can see that this commercial marketplace is vibrant with opportunity. Lots of launch capability. Now, when launch costs go down and the revolution in small sats is happening, largely led by the NASA Ames Research Center, the company Planet is able to launch and deliver the Dove, which weighs in at under 5 kilograms with better resolution at 3-meter multispectral resolution. So 20 years, we've gone from 800 kilograms to 5, launching multiple satellites at one time, providing better than resolution we were getting 20 years ago. Additionally, there are a number of companies that are finalists that are focused on managing big data. What's so exciting as we've seen the growth in cloud services, we can start to co-locate data storage and processing. So truly creating this renaissance in space exploration, and particularly in this sector, the observation of our own planet. So coming back to NASA just a couple of months ago, I found myself really excited by the opportunities, because when I left 20 years ago, limited marketplace, handful of players, really difficult to get in, and now this vibrancy. And yet, we also have some old ways of thinking. And one of the challenges that I believe that we're responsible for within the space program is to ensure that we are understanding what's happening outside. I like to think of it as outside the gate. And part of why I'm particularly excited about what you all are up to is you're bringing your know-how into our community. And as Max has been leading this nurturing and development of the entrepreneurship ecosystem, not only are we going to need entrepreneurs within the agency start to think about how to do things differently, but we need to learn from the entrepreneurs that are developing technologies and finding real market success that we can learn from. And we can all ultimately, I think, help NASA with its mission of exploration, but ultimately benefit the planet as a whole. And one thing I just wanted to share, I recognize, having started a handful of businesses of my own, I wanted to share this quote. It's a quote by Robert Metcalfe, the inventor of the Ethernet. And I found it particularly touching because I think it's often unrecognized what goes into being an entrepreneur, starting a business, building a market. And here's his quote. He says, quote, "It's the dead of winter, and I'm in the dark in a Ramada Inn in Schenectady, New York. A telephone is ringing with my wake-up call at 6 a.m., which is actually 3 a.m. in California, where I flew in from last night. Within the hour, I'll be in front of hostile strangers selling them on me, my company, and its strange products, which they have no idea they need. If I persist selling like this for 10 years, and I do it better and better each time, and I build a team to do everything else better and better each time, then I get my townhouse. Not because of my flowery flash of genius in some academic hothouse," end quote. And the reason I like that quote is you all are groundbreakers. You've got ideas that you saw there was a gap in the market, a breakdown in the market. You thought you had a solution for that market. And yet that's just the beginning of the journey. And so many of you have been on this path for quite some time, but often it is thankless and not understood of what it takes. And so as you journey with us in the iTech experience and you go through the roundtables, whether you are a winner of this session or not, I hope that you take from this learning and growth, and will continue to keep your dream alive as you push into the market and deliver the real value you know the world needs. So with that, I would pass it back to Max and wish you all a most excellent experience.
Thank you, Jason. That was great. And I agree. I think this is a really exciting time to be involved in entrepreneurial engagement because of the evolving posture that and place that NASA has in kind of the commercialization of space and the private sector's contribution to space. And I think it's an exciting time for the innovators we have here, because space markets that weren't always considered to be viable are actually becoming more and more plausible. So I think that's awesome to think about, and I really appreciate you taking the time to be with us. It was a great talk. Thank you, Jason. With that, we will move on to our next companies with Mito Material Solutions.
During the 2020 coronavirus pandemic, climatologists thought there would be a great opportunity to study emission reduction. Despite hopes of a large decline, the needle barely moved. Pollution decreased by 15% or less across the US, despite a majority of people staying home. That's because freight trailers, one of the largest contributors of carbon emissions, were still on the road making runs delivering your food, goods, and Amazon packages. Freight trailer manufacturers have been trying to shed weight and transition to composites for decades. But the current composite technology available on the market just can't handle the payload, and nobody wants a forklift falling through a trailer floor. See, composite materials are lighter than metal, but they are not as durable. They can crack, fracture, and break because the plastic or epoxy holding them together is brittle. This is one of the main reasons composites are not the go-to choice for industries looking to innovate their materials. In order to make composites more durable, they need to add something extra. Hi, I'm Kevin Keith, co-founder and CTO of Mito Materials, where we enable the use of composite materials with cost-effective additives. Mito Materials has revolutionized the polymer additive industry by creating a scalable, robust technique to functionalize graphene-based additives at an effective price. Our flagship product is Mito Ego, a graphene-based additive that is loaded into both thermosets and thermoplastics at a 0.1% concentration by weight that allows polymers to see up to a 135% increase in mechanical performance. Ego reactively disperses against itself, allowing it to be used in any manufacturing process on the market. That means by utilizing manufacturers' suppliers, there's no change in current processes. So 2 pounds of Ego can make either 3,000 carbon fiber bike frames or enough plastic parts for 5 Ford F-150s to perform like never before. Looking back at freight trailers, we know there's a need for a stronger composite in order to go the distance. That's why we've partnered with the nation's largest and most innovative freight trailer manufacturer who has been looking to transition to an all-composite trailer for the past 5 years. With Ego, we were able to push a cheaper material far beyond its more expensive counterpart with no added manufacturing time. We see here in this ultrasonic check conducted on our customers' panels that the addition of Ego does not affect panel consistency, proving that Ego is an easy plug-in solution. With just 0.1% Ego, we were able to increase compressive strength of this cheaper material by 20% on the low end and flexural modulus by 135%, hitting the benchmarks they needed to make their dream a reality. This will allow them to shed 40% of their trailer's weight while maintaining the same manufacturing process and load capacity, but remaining logistically and economically viable. Even if 55% of the 1.7 million freight trucks started using a composite trailer today, that would reduce fuel consumption by $12 billion, according to the North America Council for Freight Efficiency. That would reduce carbon emissions by nearly 60 million metric tons. But remember, composites are used in many different industries, from freight trucks and automotive to sporting goods and aerospace. One application that has been trying for decades to utilize composites are cryogenic storage tanks used for storing rocket fuel. Some of these manufacturers have gotten close, but with current technology and methods, it still has a long way to go. Now with just 0.1% by weight of Ego, hoop stresses and moduluses would increase so dramatically that not only would this application seem viable, but the increased fatigue life, bursting pressure, and toughness would finally make this the best method for cryogenic fuels. Today, the polymer additives industry is worth $10 billion, with the graphene-based sector growing 40% year over year. Sure, there are other graphene and carbon nanotube additives on the market, but all of them are difficult to disperse, require special handling procedures, and need anywhere between 10 and 40 times more material than ours. Our processes solve these problems, allowing our products to easily integrate and disperse into any polymer our customers see fit. This enables our products to penetrate markets where no one else can go. Our go-to-market strategy will focus on the thermoplastics market because of the quicker testing cycle and clear parallel to the epoxy market opportunity. To do this, we work with the manufacturers to prove ego in their products to show that they too can get drastic increases with minimal effort. We then work with their polymer supplier to integrate on the back end. That way manufacturers can utilize a Mito-powered polymer with a simple change in their bill of materials. Customers are eager to get their hands on Mito. Since launching the scaled product in 2019, we have 15 piloting customers currently testing different applications and a pipeline with over 50 leads. This approach will allow us to deliver 2 specialty product lines integrated into our current pipeline, and we are set for $124 million in revenue by 2025. But technology is half of the battle. What makes a materials business successful is the team behind the product. The team that we have assembled around Mito Materials is one that has extensive experience in B2B composite and chemical sales and manufacturing. Just like our product, we have blended the best scientific and business minds together to commercialize this opportunity. And we are backed by industry experts who work alongside us to educate an old market about new technologies. Our team is tenacious, resilient, and we know that it takes true agility and hustle to revolutionize an industry more effectively than 100-year-old companies. Since starting Mito in 2016, our team and our technology's potential has been awarded several grants and prizes totaling $1.5 million, including funds from Techstars, a NASA EPS Corps grant, and the NSF via SBIR's Phase 1 and Phase 2. That traction and track record has also allowed us to raise $1.6 million from venture capital firms and angel investors like Clean Energy Trust, who believe in our mission to empower the next sustainable material evolution by enabling manufacturers to transition to composite materials using our solutions. At Mito Materials, our goal isn't to only revolutionize how the materials around us behave. Is to create a platform technology that scales with industry standard equipment that affects said materials without disrupting current manufacturing processes. The team we've rallied behind us shares this vision and has a passion and know-how to make it possible. When we started Mito Materials, we knew that advanced materials shouldn't be accessible only to advanced industries. We knew that in order to push humanity to entirely new heights, we need versatile, disruptive technologies that unlocks this next frontier, a more sustainable frontier. That's why our products don't end with just one additive affecting one material. Mito Materials is here to empower the next materials evolution by making the products you use every day last longer and perform better than before.
Let's hear from Parasanti.
Thank you everyone for having me today. My name is Carrie Horazek, and I am the head of commercial development for Parasanti. I am very excited to be presenting at the iTech Innovators event. To quote our team's favorite movie, Interstellar, we used to look up at the sky and wonder at our place in the stars. Now, we just look down and worry about our place in the dirt. At Parasanti, we like to try to employ this mindset on a daily basis, while building the future of data for those who work the hardest. We like to joke internally that we are tech from a different type of valley. And that tagline organically grew out of the original passion points of our founders that led to the creation of Parasanti. None of us are from Silicon Valley, and we have all worked blue-collar jobs. We are veterans and farmers. We have worked outdoors with our hands just as much as in front of a computer. Now, these personal experiences provide understanding for the sector of society with jobs like these, and gives us an advantage when it comes to designing products for extreme environments, which is why we are so excited to be talking to you today about opportunities in space. In fact, both of our founders discovered their original passion for the integration of data science and edge computing through their work with NASA. Before founding Parasanti, Josh began his technical career as a network computer engineer at Marshall Space Flight Center in Huntsville, Alabama, while James worked for many years as the chief data scientist on the NASA account for Hewlett-Packard. Over the course of his career, Josh has successfully exited 4 startups, preparing him to found Parasanti and bring his vision for edge computing in a ruggedized environment to life. And the result? Our team has developed cutting-edge computing solutions for some of the most rugged environments on Earth. Through the Parasanti solution, soldiers in forward-operating, no-bandwidth environments can be in constant communication with their headquarters through a stream of biometric data, pictures of their environment, including potential hostiles, and vehicle diagnostics. Headquarters can in turn ingest and process these data through global machine learning algorithms to haptically notify the same detachment of critical insights, such as the presence of enemy combatants in the area. Parasanti's foreign object detection capability, being deployed for the U.S. Air Force, can ingest data from cloud data sources, sensors, and wide-range radar and LiDAR detection to predict foreign debris objects on an airfield. In the commercial landscape, Parasanti Edge technology can be used to track the health of individual animals in large herds across massive ranch operations. In advanced manufacturing environments, we can provide preventive and predictive maintenance analytics, and in clean tech, we are working to enhance grid resiliency by utilizing predictive analytics to monitor and shut down machinery and capacitors before they overheat. Founded within the DoD, Parasanti has fielded solutions across a broad swath of warfighting domains to include multi-domain operation projects and land operations with the USOSOCOM, as well as solutions for the Department of the Navy. We are conservatively projecting our end-of-year DoD revenue at $15 million. However, defense is just the beginning. Data architecture solutions, which operate through ruggedized hardware at the edge, represent the future of data analytics and real-time decision-making. Proudly, we are fully bootstrapped to date within our DoD business. Currently, we are splitting our company into two separate entities, which will bring our edge technology solutions to a diverse array of commercial applications. We are pursuing a Series A raise against the commercial wing of our company this August. In addition to strategic partnerships and organic commercial applications, we are exploring opportunities in infrastructure, transportation, and manufacturing. We also have a strong play in the future of farm management and smart agriculture, as well as the booming clean tech energy market. Now, our business model is built on a diverse revenue format of strategic partnerships with AI and ML shops, subscription sales in the industry and ag tech space, B2B custom builds across the DoD, the commercial landscape, and sell-with opportunities. So what exactly is it that we do? The Parasanti solution is a full data orchestration platform, which operates both within the cloud and independently at the extreme edge, providing insights when you need them, where you need them. Parasanti's value proposition is its unique ability to ingest, filter, contextualize, and process nearly any type of data through AI and ML algorithms to deliver actionable insights in a disconnected environment. Parasanti's rugged edge supercomputer processes data within the device and sends only enriched data back to the cloud, providing significant savings on both cloud storage and data transmission. Parasanti's advantage is our open architecture approach. The orchestration platform allows integration with nearly any data source available. Furthermore, our software was constructed with NSA-level security standards built in. We offer full data provenance, lineage, and pedigree right there at the edge to allow for replayability, essentially giving insight to where, when, and why something happened. Our goal is to provide a data orchestration platform which can amalgamate and process heavy data streams, whether they're from IoT devices operating at the edge in zero bandwidth environments or in a data center in the cloud. Parasanti's heavy lifting supercomputer weighs in at only 5.5 pounds and can sit in a factory, attached to a vehicle, or even be carried into space. It delivers 31 tera operations per second. It is IP67 environmentally sealed and operates on 512 CUDA cores. It processes 12 1080p cameras at 60 frames per second, bringing in an enormous amount of compute to the extreme edge. Our GPU-driven data orchestration platform, Parasanti Nightfall, is designed to host extremely heavy ML workloads. With 800 different data connectors, Nightfall can connect to virtually any type of data stream. And finally, we are the most energy-efficient edge computing device on the market, currently clocking in at 0.5 watt per tera operation. Our proprietary Nightfall software, which is built on a strong, no-code, low-code infrastructure in a disconnected edge architecture, makes our offering extremely hard to imitate. And while the edge computing space is a relatively crowded field for such a nascent industry, Parasanti is unique in its offering. Our primary competitor in the public space is Palantir. We also have several niche competitors across agriculture, industry, and energy, including Farmer's Edge, Blueforce, and Clearblade. The majority of our would-be competitors, however, offer niche solutions which specialize in specific clients and industries or overly focus on the data visualization component. As a protocol-agnostic data orchestration platform, Parasanti provides the backbone to edge compute for numerous AI and ML applications. Our founders have envisioned space as the final frontier to really prove out our solution. Space is a fundamentally different type of operating environment. Performance constraints change rapidly and dramatically. In addition to extreme cold and heat, radiation is a constant challenge. Power is finite, and hardware is often a long way away from the original power supply. Maintenance is complicated by sheer physical distance and/or lack of device-specific technical know-how from the astronaut team engaging with the tech. In other words, to operate effectively in space, solutions must be able to withstand extreme temperature shifts and radiation exposure, operate for a long time on low or self-renewing power, and have the ability to fix themselves. And that's why we invented Space Ghost, a ruggedized supercomputer retrofitted with hardware specifically designed to withstand the extreme environment of space. Powered by one of the most secure high-compute data orchestration softwares on the planet, Space Ghost brings all of the bells and whistles of our Earthbound solution to a hardware upgrade designed to excel within the unique operating environment of space. The hardware has no moving parts, conduction cooling, error-correcting memory, and is encased in heat-sink metal plates to withstand the impact of EMI. Our software has been layered with a full DevSecOps approach, enabling the device to shut off in the presence of extreme heat, turn back on when conditions are more favorable, and even to fix itself. If a line of code fails, the hardware can change it and retry. We have also partnered with a leading-edge battery developer, Direct Kinetic Solutions, to fit the device with an isotope-enabled battery, which acts as a mini nuclear reactor to the device charging. Envision a next-generation telescope enabled with our Space Ghost technology. The device is processing deep space imagery as it is captured in real time by external cameras. Mid-flight, the probe is exposed to a solar flare, and suddenly it's 300 degrees hotter than it was 5 minutes ago. Now, normally such an event would cause the system to overheat and the technology to fail. Through our development operations process, Space Ghost will preemptively turn off the device and turn it back on when we are within the correct operating environment. In addition, the AI and ML capabilities encased within the device would enable the operator to change the analytic mission mid-flight should a new research approach be needed after launch. Now, we anticipate a bright future for our company moving forward on Earth, but we know that space is the final frontier. Our primary barrier to entry is lack of a strong partner who can help us develop a working prototype for the Space Ghost program, which brings us to our ask. We feel a partnership with NASA would accelerate the Space Ghost product while greatly enhancing our data orchestration capabilities, specifically by giving us support to enhance the metal coverings of Space Ghost to withstand cosmic radiation and allow us to test the full capabilities of the isotope battery. Enabling NASA missions with Space Ghost could allow the agency to push the boundaries of space exploration. Self-powered, self-correcting, ruggedized AI enables us to treat space exploration differently by pushing the boundaries of current capabilities in deep space. AI can boldly go where no man or woman has gone before. Thank you.
Next, we'll hear from How Industries.
Water. We owe quite a lot to it. It's essential for life on Earth. It keeps us cool on a hot day, waters crops for food, and at one point in time drove the largest industrial revolution the world has ever seen. Mills, factories, trains, all powered by steam, have propelled humans into the 21st century. But our modern technologies have made steam power obsolete, leaving old technologies forgotten in time. Now humans are on the cusp of a new revolution, this time in space. Small satellites by the hundreds and even thousands will be launched, gathering data and connecting our world in ways that were previously unimaginable. In order to expand this revolution further and truly realize the potential of these satellites, we have brought back an old friend, STEAM. Combined with decades of technology, advancement, and modern insight, STEAM is being brought to space in a way never seen before.
While a satellite seems complex, its basic needs are rather simple. Chief among them is the need to move around in space with a propulsion system.
Without this, they face a bunch of different issues. Satellites will naturally decay as they interact with the upper atmosphere, hurtling themselves all the way back down to Earth. If you're spending hundreds of thousands, if not millions of dollars on your satellite, you're going to want your investment to last. If you're like most satellites these days, you're probably pretty small, which means you're rarely going to get your way during launch. You usually get dumped out into space with all these bigger guys that chose where to go because they paid the extra money. And if you have high hopes and dreams of going to Mars or the Moon, better luck next time. That's where Thermostat comes in. Thermostat is a solar thermal propulsion system, meaning that it gets all its energy from the sun, and it stores this energy on a thermal capacitor, which works just like a regular capacitor, but this time storing their energy as heat. If we take water and we introduce it to that capacitor, it instantly vaporizes into steam, and if we can channel that steam into a nozzle, we get thrust, and thrust is movement. But why solar thermal propulsion with all these other systems available? Well, for starters, our system does not require electrical power conversion. We take the energy of the sun and place it directly into our thermal capacitor. The hotter we can get this capacitor, the more efficient our propulsion system becomes. Our first systems are planning to use water as a propellant, which is safe, non-toxic, and inert. I can drink water, but I can't drink hydrogen that powers other systems. But we all know the real reason why someone would want to use a propulsion system in a spacecraft. Space is expensive, and building a single satellite, let alone a constellation of satellites, is going to add up. Satellites are naturally going to deorbit in a few years, depending on their altitude. These deorbiting satellites cost a lot of money. Take this Earth observation CubeSat, for example. It's 6Q, which costs about $300,000 to send into orbit, not counting the cost of actually building and the labor involved with making that satellite. Now that's pretty pricey. But if your satellite keeps dropping out of the sky every 3 to 5 years, you're going to need to replace that over and over. This is where Thermostat comes in. Thermostat can keep your satellite in orbit longer by boosting your orbit over time to prevent yourself from burning up in the atmosphere. With a little more upfront cost, you can drastically reduce your replacement costs and increase the net throughput of data from that satellite. Thermostat enables you to move around in space and explore and commercialize areas that were previously thought impossible to reach. Let's say you want to provide better image or lower latency for your customers. One method to do that is to spend thousands and thousands, if not millions of dollars on research and development to develop a new communication system or a new camera with a better resolution. Another method is to simply lower your orbit. By lowering your orbit, you are able to increase your spatial resolution without actually changing the payload you have. Thermostat can keep you alive at these altitudes, matching the lifetime you had at your previous orbit, while simultaneously increasing the product you're bringing to your customer. Our baseline thermostat unit is designed to fit with CubeSats and small satellites to accomplish this task, but our technologies don't stop here. We are developing Thermostat 100, a spacecraft designed to operate at extremely low Earth orbits. This region of space typically goes unexplored as it's difficult to get to, but there's lots of science and lots of commercial opportunities in this area. The drag is high enough in these orbits that a typical CubeSat will deorbit in a few months, weeks, or even a few hours, depending on what altitude they're at. But why do you care about winning this orbital limbo contest? Being low, as we said, gets you better spatial resolution and lower latency communications, but there's also other huge implications that people can take advantage of. With your orbit being lower, you're going to be moving faster than the satellites above you, so your revisit times can actually decrease significantly based on your altitude. Other payloads, such as radiometric observations, see a vast improvement with being closer to the ground. They require less sensitive equipment that would be required in LEO because of all the extra altitude between you and the ground. Geopositional accuracy also improves because of your physically closer distance to the surface of the Earth. Your satellite and payload will suffer less radiation effects because of your closer distance to the Earth. Any orbital debris in this area is going to quickly deorbit because of the increased drag, a problem that's going to occur in low Earth orbit with the thousands, if not tens of thousands of satellites that are going to be launched. This region also encompasses the ionosphere, a rarely studied region of space that actually greatly affects communications for NASA as well as the military. Thermostat 100 has been specifically designed to meet the requirements of this challenging environment. By including your payload in Thermostat 100, you're able to bring the same, if not better, services at a cheaper price to your customers. But what about those who want to break free of the bonds of Earth? Those that want to explore to the Moon or even Mars? Thermostat Plus is the answer. To address larger satellites and a growing cislunar economy, Thermostat Plus has been specifically designed to transport cargo and last-mile services to the Moon and beyond. This system takes solar thermal propulsion to a whole new level. Utilizing hydrogen as a propellant, Thermostat can achieve extremely high specific impulse and thrust values, typically only seen with nuclear thermal rockets.
This is all without the adverse effects of having to deal with nuclear materials and launching them into space. Thermostat Plus offers tug services in Earth orbit, geo, cislunar space, and eventually all the way to Mars. With unparalleled efficiency and thrust, Thermostat Plus will truly open the cislunar economy and beyond. While this is the future we envision here at Thermostat, we need to take incremental steps. Our baseline system will be debuting in 2023, featuring a system that will fit into 6U and larger, as well as 3U or larger satellites. Thermostat 100 will be introduced in late 2024, with Thermostat Plus shortly following in early 2025. Sales as well as investor funds will help finance the research and development for these two larger systems.
In this figure, you can see how other systems compare to each other when we consider their power consumption and thrust levels. On the left-hand side, you have electric propulsion systems, which, while extremely efficient, produce only a small amount of thrust, requiring lengthy time frames to deliver payloads to specific orbits. On the right-hand side are systems that produce a large amount of thrust, such as chemical systems. These systems are fast and maneuverable, a considerable advantage in crowding orbits and a rapid deployment of constellations. The Thermostat baseline unit requires only a small amount of power from the spacecraft, getting most of its energy for thrust from the sun. Combined with water as its propellant, it can produce thrust on par with other high-thrust monopropellant and bipropellant systems typically classified for CubeSats and small satellites. Thermostat Plus sits in the upper right-hand corner of this chart with extremely high specific impulse compared to other high-thrust chemical systems. This enables an extremely efficient and maneuverable thruster for in-space transportation.
Our projections place our minimum viable product addressable market at just over $72 million. The Thermostat baseline unit will act as a stepping stone for our other technologies that have the potential to really disrupt the current industry. Thermostat Plus in particular will address the last mile services and in-space transportation that is quickly growing. With high thrust and specific impulse, Thermostat Plus can only be matched by another solar thermal system or a nuclear thermal option. The expected market potential in this area is expected to quickly increase to over $10 billion in 2030. With increased interest in cislunar activities, we believe this market will grow even further. The team is led by Dr. Troy Howe, the founder of our parent organization, Howe Industries. He has expertise in nuclear power and propulsion systems. And while we have taken the nuclear power out of Thermostat and replaced it with solar thermal, his expertise in this area will lead Thermostat to success. Our CTO, Jack Miller, was the lead engineer for the Thermostat Phase 1 SBIR with the National Science Foundation. He led the development efforts for this propulsion system, as well as led the team, the National Science Foundation's I-Core program. Our managing director, Marvin Weinberger, is a serial entrepreneur and inventor. He has led many successful companies to great success, and his guidance with Thermostat leads us to a promising future. Thermostat has been funded by a National Science Foundation Phase 1 SBIR grant in 2019 and 2020. We are eagerly awaiting a Phase 2 proposal. We have also been subcontractors on several Air Force SBIRs, with companies leveraging our technologies to increase the access to space and the cislunar environment. In the coming months, we will spin off Thermostat from Howe Industries, its parent organization, and retain an investment banker for a Series A. We are currently seeking $5 million in Series A funding. We will use these funds to develop Thermostat and make it into a product that is truly commercial off the shelf and readily available. This funding will also go towards the research and development of Thermostat 100 and the Thermostat Plus propulsion system. Funding will also be used to expand our team, bringing valuable talent to the success of Thermostat. Steam has powered an industrial revolution in the past, and now it's time to bring that technology back to drive our own revolution in space, powered by Thermostat.
Next, we'll hear from Full Cycle Bioplastics.
Imagine going to the grocery store and the bread, beans, or pasta that you pick up comes in a bag. But instead of traditional plastic, that bag is made out of food waste. To you, there's no visible difference in color, clarity, food freshness. It's just a bag. And when you're done with it, instead of throwing it in the trash, you put it in your compost bin, where it'll be turned into something else. That's the circular economy. That's what we're working towards. The system we have now is more linear. We use energy, water, and labor to produce food, and in the US, we waste 40% of that food. It's a ton of wasted resources, and unfortunately, that's become the global norm. Oil-based plastic pollution and organic waste generation and landfilling are huge drivers of climate change. We need to change our mindset about materials production and waste management. The take, make, waste model doesn't work anymore. Luckily, we have a circular economy solution that addresses waste, pollution, and climate change. My name is Delane Mayer, and I work with Full Cycle Bioplastics, a California-based biotech company whose patented IP turns organic waste into a non-toxic, compostable plastic alternative called polyhydroxyalkanoate, or PHA. PHA-based plastic is fully customizable to its intended application, and it degrades harmlessly in the natural environment if not upcycled into virgin resin. The full cycle process has 4 key steps: waste collection, anaerobic digestion, where waste is converted to volatile fatty acids, or VFAs, aerobic PHA growth, where we fatten the VFAs up, PHA production, where bacteria convert the VFAs into PHA and we extract it, and from there, a PHA-based product is made, and ideally at the end of its life, it's upcycled back to step 1. No matter how mixed that initial waste feedstock is, our VFA intermediate is homogeneous. Our end product, our base PHA, will be the same no matter the diversity of waste put into the system. Full Cycle's PHA is the most cost-effective in the market, thanks to unique technological advantages in our patented process. Other bioplastics manufacturers rely on food source feedstock as a critical input. They grow corn, soy, or canola, employing agricultural systems that aren't cheap and that have a big land, water, and carbon footprint. We source waste that would otherwise be landfilled, thus reducing methane and carbon emissions and dropping our costs. Our PHA is different too. Our PHBV is a tailorable co-monomer, and we can replace a wider variety of traditional plastics with it. Our diverse feedstock sourcing allows us to generate valuable precursors that are expensive to produce commercially from synthetic or food crop feedstocks. Our PHA gives the consumer the widest application range biopolymer. And thanks to our feedstock sourcing, Full Cycle offers the lowest cost, lowest carbon alternative to oil-based plastics available in the market today, bringing the circular economy well within reach. We're working with some of the biggest food manufacturers in the world, brands you probably have in your cabinet and fridge right now, to replace the plastics in their supply chain with food waste from their facilities. We've proven this concept at our successful commercial demo site in Mountain View. Here, we take 400 pounds of food waste a day generated from an assembly kitchen and turn it into PHA. At our on-site analytical lab, we evaluate the process and execute research for clients. This revenue-generating research is part of our business model. We analyze a partner's waste for feedstock potential for PHA production, or we examine plastics currently in use in a partner's supply chain and develop PHA with matching specs to replace it. There is so much demand for this research that we have to build an additional facility. The more research we do, the more we de-risk commercial scale partnerships. So we're developing a fermentation warehouse, a state-of-the-art and first-of-its-kind research facility. This warehouse of bioreactors will produce a variety of base PHA resin types to advance R&D, IP development, and commercial traction. Additional material production and R&D capacity will allow Full Cycle to more effectively engage large clientele interested in purchasing PHA. We'll advance from TRL 8 to TRL 9 as we commission our first licensed facility in New Zealand and develop a commercial scale facility in California. We do this work thanks to an amazing team of dedicated material alchemists, bioengineers, business developers, and tech wonks who are all driven to catalyze the circular economy. Full Cycle's co-founders and co-CEOs, Dane and Jeff Anderson, brought Full Cycle into force in 2014, moved to address the plastic pollution they experienced while surfing. Dane is an inventor and engineer specializing in automation, biological wastewater treatment, green chemistry, and scaling technology from lab to commercial scale. Jeff is an environmental engineer whose graduate work focused on the economics of PHA production. Full Cycle has since expanded to a team of 35 and counting, which is good because our pipeline includes $30 million worth of potential projects. Our business model includes 2 funded research pathways: feedstock feasibility studies and PHA-based product development, as well as technology licensing. Feedstock and waste providers who generate or manage large volumes of waste can turn their waste cost into a sustainable revenue stream by turning that waste into PHA. We first engage providers in a feedstock feasibility study, which characterizes their waste as potentially viable feedstock and provides a go-forward plan for commercial-scale waste offtake opportunities. For organizations looking to co-develop PHA-based products, Full Cycle will work with partners to develop a custom PHA copolymer with the aim of displacing a plastic currently used in their supply chain. This helps companies achieve sustainable packaging goals, differentiate their products, and de-risk their supply chains. Lastly, technology licensing of Full Cycle's IP helps scale PHA manufacturing. Licensing Full Cycle's tech helps meets the demand for PHA, increase revenue for Full Cycle and licensees, create high-value sustainable products, and addresses the local and global impacts of climate change. Ultimately, we can partner with anyone who produces waste or who wants a biobenign alternative to plastics in their supply chain. This business model has been well received by investors. In early 2021, we raised a $2 million safe note from angel investors, and at the end of April, we finalized a $5 million safe note from a private equity firm. We're in the process of finalizing our $20 to $30 million Series A round now, too. This funding will go towards our R&D fermentation warehouse, where we'll conduct more paid research, our California commercial facility, and our New Zealand licensees facility, all of which will help grow the PHA market. The global plastics market was $450 billion in 2019 and is expected to grow up to $750 billion by 2028. Within that, Full Cycle sees a $270 billion market opportunity to disrupt both the traditional and bioplastics markets. Currently, demand for PHA is so huge that one of the larger PHA producers in the world expects to be sold out through 2024. There's a lot of room in the market for emerging biomaterials manufacturers. Terrestrially, we're scaling up to meet global demand, but we're interested in scaling down too. Beyond Earth, PHA's tailorability to use specification and end-of-life target makes it a unique and valuable material in space. PHA has the potential to enable circular product development on the ISS and lunar settlements. Our process could produce PHA-based 3D printer filaments, PHA protective padding for sensitive equipment to survive launch, or replace LDP food packaging. Our technology could even be designed to transform human refuse into a PHA-based material for construction. In our process, there are no hazardous byproducts or combustion risk, and even during extraction, we use bioprocesses to purify the polymer, so it's a benign process. We're developing automation on the analytics to ensure quality, and while we currently rely on technicians, our future system will be autonomous. Anaerobic digestion has and should be researched for long-term lunar missions as a solution for waste management, fuel generation, and manufacturing in space. But let's get one thing clear. This planet needs the circular bioeconomy to succeed. We need all kinds of biodegradable PHA in the marketplace. But unless NASA is planning to ship up canola, soy, woody biomass, or some of the other feedstocks required by other PHA manufacturers, Full Cycle's technology is the only waste to PHA option in space. We're interested in continuing the conversation to discuss replacing plastics in NASA's terrestrial supply chain, as well as supporting Artemis, Gateway, and beyond. The circular revolution is here, in space and on Earth, brought to you by Full Cycle.
Next up, predictive care.
Hi, I'm Alex. I'm the co-founder and COO of Predictive. I am an electrical engineer and started my career in strategic consulting in companies such as Accenture, PwC. I was also a partner at KPMG. 10 years ago, I founded my first startup company that got successfully acquired 2 years later. I then went back to Europe, where I'm from, to found the first fintech accelerator in continental Europe, the Cube, that also got successfully acquired 2 years later. I then decided to move back to Silicon Valley, where I'm currently based, and I had the amazing chance to meet Sajong. And he told me about that great project he was working on, a technology that would automate the entire DNA analysis process. This is how Predictive started.
Predictive is the most advanced DNA-based digital twin to predict and prevent diseases and adverse drug reactions. I'm Sajung, CEO and co-founder of Predictive. My life mission is to save the most lives. My team members agree that the most effective way to do so is to save the savable lives. Every year, 55 million people die from serious diseases. However, 10% of these people, which is 5 to 6 million people every year, should have not died from it because these diseases, their diseases were predictable and preventable.
So what is Predictive? Well, if you remember the movie Minority Report with Tom Cruise, he was using a solution that enabled him to predict crimes before they happen so he can prevent them. We provide a solution that is very similar to healthcare professionals. We provide them this solution that enables them to predict diseases before the symptoms appear so they can be prevented. And to do that, we sequence your entire genome, your 20,000 genes. And that enables us to assess the level of risk on 22,000 diseases, to simulate drug reactions, personalized drug reactions, to over 750 drugs. And we made a solution that is easy to use by any healthcare professional, no need to be a genomics expert. We have that solution that is not just a PDF report, but that is real-time and searchable. So basically, what you can do is you can Google your DNA. You can search by gene, by disease, by drug, by chromosome. So you can search all by drug, all that, just in one toolbar. And because we assess and analyze your entire genome, we have a solution that evolves over time because science evolves very quickly in that field. And so does your digital twin. So how do we do that? Well, other alternatives on the market look at a limited number of gene variants and a limited number of diseases. And the reason why they do that is because every time they want to assess the level of risk on a disease, they have to manually look into the research papers. What are the gene variants associated with that specific disease? What we have done is that we have automated the entire process. So we look at 100% of diseases known to have a genetic component. We look at 100% of your genome. And based on that, we're able to match and to assess the level of risk for all diseases, for all your gene variants. We are primarily a B2B solution. We provide our solution to hospitals, telemedicine companies, physicians. And they are the ones who will recommend or prescribe our solution the same way they do today for other genetic tests. Once the patient gets the kit, he will just have to get a few fingernails, send it back to us. We will extract the DNA with our proprietary protocol to extract DNA from fingernails. We will sequence the entire genome thanks to next generation sequencing technology, and then we will analyze it. And at the end of the process, we have a genetic counseling session, which is key because we provide the data to predict the diseases, but we want also people to get out of it with a preventive plan. To build Predictive, we have set up an amazing and complementary team with Sajung and his identical twin brother, Sijong, both genomics and bioinformatics experts and teaching genomics at Johns Hopkins, myself, serial entrepreneur, Alexander Bresfold, a full stack software engineer who's our CTO, Mylene, who's an MD physician and Johns Hopkins trained bioinformatician, and Shivam, our head of growth. So we launched in February this year and already have had amazing traction. We have signed with over 200 hospitals, 3,300 physicians. We are currently deploying our solution to them, but we are very excited to have such partners. We have also signed our first contract for our nutrition product with a Quality of Life, an online retailer for vitamins and supplements. So we're having all that great traction and so many reviews and comments from people excited to have those results and to be potentially able to predict diseases for them or for people close to them. We also have the chance to have two great investors. First of all, Plug and Play Ventures, one of the largest early stage investor in the world, who previously invested in PayPal, Google, Dropbox, and recently Tim Draper, who's leading our $1 million pre-seed round. Tim Draper being well known for being an early investor also in Tesla, SpaceX, Twitter, and many others. We are deploying our solution in 9 countries on Earth, and many more to come. But what about space? What about other planets?
One effective use of digital twin is to maximize the life cycle of a machine. I'm sure NASA monitors every component of spaceship by digital twins. One of the NASA's Mars exploration program goals is to prepare human exploration in the 2030s. Individualized digital twins of human astronauts would be an effective way to ensure the safety of humans in those long-term space missions. DNA is a blueprint of human health. As shown in the twin study, cosmic rays mutate the human DNA differently than the Earth environment. When germline DNA got mutated, wrong proteins kept made, and the person before and after the cosmic rays is basically a different person with a different genotype. Therefore, long-term space travelers, including the astronauts, need to have their DNA-based digital twins made regularly by check epithelial cell swaps, as the cells divide very frequently every 24 hours, and it is the area constant shedding take place. And an entire genetic profile needs to be analyzed per digital copy version of themselves over the space travel. Predictive. We have developed algorithms to analyze human beings' entire 20,000 genes for 22,000 diseases, and that includes 10,000 significant diseases in real time by automatically building DNA-based digital twins from genomic sequencing data. We are hoping to provide our DNA-based digital twins for human healthcare to astronauts of long-term missions like the Mars exploration program and ensure the health safety of human habitat in Mars in the future. Thank you.
Last but not least, we'll hear from Blue Space AI.
Future of autonomous vehicles is coming, but with a cost. According to a RAND Corporation report, it would take 8.8 billion miles to demonstrate equal reliability of an autonomous vehicle to the reliability of a human driver. Not only are we nowhere close to that 8.8 billion miles, the reality is pretty grim. As we read in the media, horrible crashes on the highway and another senseless fatality after another with a careless mistake. While the future with autonomy is very promising, accidents by robots are happening, and it's costing us capital, time, and our lives. Now, we don't want these accidents to happen in space, let alone Earth. While we try to perfect perception, and prediction in the AV stack in many different ways. Driving millions of miles, for example, having human in the loop with remote monitoring. In space, all these options, driving millions of miles or relying on mapping data, presents additional challenges. Furthermore, the need for lower latency, lower compute power, and the limited budget, and the challenges of mapping are all exponentially even more challenging in space. Hi, I'm Christine Moon, co-founder and president of BlueSpace.ai. We're a software company based out of Santa Clara, California. We are using the latest Gen 4D sensors to enable perception for all autonomy here on Earth and in space. BlueSpace brings together a team of AV veterans who've worked at global OEMs, world-class research institutions, and leading autonomous vehicle software tech companies. BlueSpace's breakthrough is twofold. First, it's the theory, the discovery and the derivation of the relationship between objects' true motion and the observed sensor data, enabled by the latest sensors such as the FMCW LiDARs or imaging radars. As we have seen in the past, new insights allow for new capabilities. BlueSpace's theory, which is the first breakthrough, allows for us to build perception software for all autonomy, which is the second breakthrough. Similar to the discovery of E = mc squared, while in theory it's explaining the energy released in an atomic bomb, it does not explain how to build one. And that's the second breakthrough of BlueSpace, where we have built the robust and generalizable perception software stack to put our theory into practice. And we believe that this will enable and accelerate a safer and scalable path to commercializing autonomy. Autonomy is already all around us, and we will continue to see more AVs in ride-hailing, delivery robots, or AV trucks here on Earth. Autonomous hauling trucks have been used in mining for decades. Robotic combat vehicles in military has also been deployed. And NASA is no stranger to developing autonomy. As an example, let's talk about the tale of twin rovers Spirit and Opportunity that were sent to Mars simultaneously. As you can see, one had a lifespan of 14 years, and the other, Spirit, had less than half of that. And you can see how productive one was in providing raw images, while the other one was less than half of that. So what happened? Well, as you know, Mars rover exploration has many critical tasks, but as the tale of twin rovers tells it all, when one of them got stuck in a terrain where it was not familiar with and couldn't get out, it prematurely ended its mission. Other examples are where there's growing congestion in outer space. So the fact that precision in perception and being able to predict the motions of the object around us can be applicable to space is very, very close in the near term. There are three key values that BlueSpace brings to the industry. First, it's the reduced latency. Traditionally, an AV takes snapshots of the environment over many different frames, one to classify objects, then to determine the movement surrounding the vehicle, and to infer where moving objects will go. This will be key input for the vehicle to navigate safely. BlueSpace does not infer, but measures all current velocities with accuracy instantaneously in one frame. This allows for reduced latency, and that means we can react faster to all scenarios. Value 2, less power hungry. Taking multiple snapshots and processing this data traditionally takes lots of power. Many compute chips on top of the CPU, such as the AI chip and GPU. BlueSpace takes a leaner and smarter software approach. Therefore, we do not need as much processing power for autonomous operations. Third value would be removing the need for classification and thus reducing external dependency. Because we instantaneously compute the motion of the objects rather than inferring based on classification, we can handle endless edge cases, or the long tail of small problems, as Elon Musk calls it. Inference only works for use cases that the training data set was collected for, and the vehicle would have to continue collecting and training indefinitely to maintain an accurate performance and not cause accidents. And this has turned out to be an insurmountable task that's endlessly using capital and time to do and to perfect. That's why Blue Space's approach, having a generalizable solution to endless cases, allows us to scale faster to new environments and be able to have the confidence that we will not cause harm. The total addressable market is large, both on Earth and in space, and on and off-road applications. That said, we do anticipate faster adoption in the enterprise commercial space, and the consumer space will follow. The commercial AV market includes industrial, defense, mining, indoor warehouse, etc. Now, let's take a look at our software. Remember, it doesn't matter the computer has never seen the object before. It doesn't matter there are no lane markings in the terrain. It does not matter that we don't have mapping data to support our software. So in the video clips of our software, you'll see that our software, number one, detects the vehicle, the pedestrian, the scooter, or the pedestrian wearing boxes. And then furthermore, it's able to predict the motions of the objects as well, thus allowing for the vehicle to navigate safely. These are just prompters. Oftentimes our customers will bring relevant examples to test for the scenarios they care about and thinking about how this software can really enable them to scale their operations. So anything in our field of view, we will detect and measure the true motion of that object. Now, that's scalability. No prior training needed, no reliance on mapping. Our commercialization path with our patented technology starts with our early access platform. Through our early access platform, our customers get to test our software firsthand. So instead of spinning up a team of 30 PhDs, they can take our early access platform to see the power of our perception system that will give the motion certainty and be able to operate in new environments. This perception in a box is a pre-calibrated sensor hardware and our software on top of low-power automotive-grade embedded SoC in a single unit. There is a minimal integration effort for our partner. Only power supply is required for our early access platform, and no data is needed from the customer's vehicle to Blue Space's platform. We have patented our technology in the US and internationally. For the next 12 months, we will have proof of concepts and NREs, and that will convert in the following years to licensing our technology. You can see that the range of our revenue and the projections can vary depending on the number of partners. What's interesting to note is that the profit margin starts in single digits, but quickly ramping up to upper double digits in the 4-year horizon. In 2019, we raised a seed round of $3.5 million. Currently, we're in the midst of raising our next round of financing. This is to really grow the team so that we can engage with partners globally. Autonomy will transform how we work and move here on Earth and out in space. We'll be able to expand our boundaries of where we explore to increase the safety of our personnel and vehicles and to further aid missions of NASA. Blue Space provides the safer, scalable solution to harness autonomy for all missions. We provide perception without compromise because you and your mission should not be compromised. Thank you.
Max, back to you.
That brings us to the end of our company pitches. I'd like to thank all the companies for all your hard work. For those who are interested, we've included links to the individual question and answer sessions for each company as bonus material for folks looking to get a little more insight into the companies and what the judging panel is looking for. During our live events, the time after the company pitches is used for judges' deliberation and a speaker or panel addresses the live audience that's waiting in suspense. Although this broadcast is pre-recorded, we have chosen to stick with that tradition, and I hope you enjoy the content. Our featured speaker is Dr. Claire Martin, the Executive Vice President of Astroscale, a company focused on providing sustainability in the emerging space economy. Dr. Martin will be interviewed by longtime friend of NASA iTech, Jen Consalvo, who does great work for us sourcing, recruiting, and coaching iTech companies. She brings 25 years of experience in the tech world, including developing products for AOL and starting her own company, TechCo Media, which was acquired in 2017. She then built and led a consultancy called Established, which builds networks for startups and innovation programs for organizations ranging from the Fortune 500 to the Air Force. She also runs the Startup of the Year competition and is part of both Established Ventures and Next Gen Venture Partners. Over to you, Jen.
Thank you, Max. We've had a number of innovators to the iTech program this year with a focus on sustainability, which we know is only going to become more important in the future. So with that in mind, I'd like to introduce our guest today, Dr. Claire Martin, Executive Vice President at Astroscale US, who brings many years of space technology management, operations, and engineering experience to the Astroscale team. Previously, Dr. Martin was the Director of Orbital Solutions at General Atomics Electromagnetic Systems. She was responsible for the management and technical performance of the engineering staff and delivery of projects. Prior to GA EMS, Dr. Martin was the Chief Operating Officer at Surrey Satellite Technology US. She joined the US organization after holding several positions with Surrey Satellite Technology in the United Kingdom, including the head of the telecommunications and navigation business unit encompassing the Galileo payload program. Dr. Martin earned a Master's of Science in Astrophysics and a doctorate in Mathematics and Computational Sciences from the University of St. Andrews in Scotland. Welcome, Claire.
Thank you, Jen.
It's great to have you here today. So let's talk a little bit about Astroscale. Can you tell us a little bit about its mission and business and how you see it contributing to a sustainable future?
Yes, of course. So Astroscale as a company was founded in 2013 by a gentleman called Nobu Okada. And he had a very clear vision that he wanted to bring a more entrepreneurial solution to the space debris problem. So these days, we very much have a vision that we are leading the sustainable development of space for future generations. And we're doing that in our business by not just looking at one hard problem, Jen, but three. We are looking at the technology in order to be able to perform on-orbit services and remove debris from orbit, for example. We are looking at the business aspects of that. So how do you establish your business? How do you close your business case? How do you make this a sustainable on-orbit servicing future? And third, the policy, because in order to achieve the first two, you need the policy and regulation in place to support such an on-orbit infrastructure. So as a business, we're very active in all three domains, even here in the US. And it really does make for an excellent place to work because you don't just have one thing to solve in the morning.
That's amazing. So space debris, actually, can you tell us a little bit about this problem?
Oh, yes, of course. So that's actually where I very first started my career. I was a space debris analyst back in the UK. So space debris is a growing problem. It's made up of anything in orbit really that's not performing a useful function, anything man-made. So there's old satellites, there's old rocket bodies, there's bits of fragmentation debris from collisions and explosions that have occurred. There's even, paint flakes, the odd tool that may have been dropped. So really anything man-made in orbit. And over the last couple of decades, especially, we've been increasingly using Earth orbit to support applications here on Earth. And that population has seen a surge. We are seeing another surge now due to a couple of collision events and also due to the mega constellations adding and increasing the population on orbit. So really now is the time to sort of take a step back and have a look and make sure that we are truly addressing the core of the problem.
Wow. So we've really, just in like 60 years in space, we've developed some really bad habits, it sounds like. So how, you mentioned a few ways that happens. How do we prevent similar things happening as we continue to forge forward to the moon and to Mars and extend our human presence even further from Earth? What kind of habits do we need to build now?
Well, we need to, think holistically in a sustainable way. But the thing where we are now compared to where we were 60 years ago is we're a lot smarter about the problem. 60 years ago, space was new, and we definitely had the space is big kind of philosophy. And I don't disagree with that. Space is big. The entirety of my doctorate was on star formation. But what we probably didn't realize enough at the time was that there are very specific orbits which we all want to use. There's a very specific one, a geostationary orbit for communications, and Earth observation all like to have consistent shadowing, so they're all in very similar orbits as well. So as we move outside of Earth orbit and we extend our horizons to the Moon and Mars, then we need to start having that conversation now. So don't wait till we've had a problem, but actually have the conversation now and think about how we can fold the lessons that we've learned over the last 60 years into the design and development of these satellites and missions that will be going to those places.
Right, right. So looking beyond debris, what does sustainability in space for the entire space industry at large mean to you? And why is that important to think about now?
Well, for me specifically, I'm a huge believer in the amazing advantages that space can give to everybody on the planet. And the accessibility to that environment and benefits of that environment should be available to everybody. So I said I started my career as a space debris analyst, which is when I first knew about the problem. And then I actually spent some time, as you said, with Surrey Satellite building small spacecraft. And there it was very much a vision of trying to keep space from being just the purview of very wealthy governments. And having a sustainable environment is essential to maintain that accessibility, to keep those benefits for everybody, everybody day to day, whether you're trying to navigate to the restaurant to meet your friends for dinner, or you're climbing Mount Everest and you want to phone someone to tell them you made the summit. There are so many ways that we use the assets in orbit, and to keep doing that, we have to have a sustainable outlook.
Right. So some of the focus areas for this particular cycle of iTech have focused on reusability of packaging, sustainable logistics, resource optimization, and we've attracted companies that are working on sustainability on Earth. So how do you view that intersection of terrestrial and space sustainability innovation? So where those things potentially come together?
Yeah, the very short answer, Jen, is I love it. I have always been passionate about bringing terrestrial technologies, lessons learned from other industries into the space industry. So I think there is a lot that we could learn from each other and work on together. There'll be elements, of course, where the technology is completely different, where you have to address the fact that it's expensive to get into space, and you have obviously a vacuum problem and a distinct lack of human presence. But to learn, especially, I think probably on the policy and regulation and how you educate the public to the challenges of being sustainable. I think these are all great topics of discussion that we should definitely have a connection between the terrestrial and the space environment.
So let's go back and talk a little bit about the crowdedness of space and where we're going, right? So if you think about Earth and the invention of the automobile, initially there weren't enough to ever care, right? Like there were so few of them that it didn't really matter what was coming out of the tailpipe. So we could ignore any consequences. And then, it just boomed, right? And now when you look at the fact that the average American household might have 2 or even 3 vehicles, it's a problem. And now we're all very aware of it. So similarly, when low Earth orbit was first being utilized, the chances of collisions were pretty small, right? And people really didn't think about this vision of a crowded lower Earth orbit. So how can we make sure that that as operations in space become more common, and we're just sending up, I think there's projections for how many thousands more satellites being launched into space, CubeSats, larger satellites. How do we take into account the potential for dramatic increase in scale in a responsible way?
Oh, that is a very good question. So, we're seeing a pretty dramatic increase now, actually, with the mega constellations that are going into low Earth orbit. I think a large part of it is education. And a lot of what we do here is try to bring that thought leadership to make people aware, so that I didn't know is no longer a good reason for not doing something to help the environment. And I think probably the second big thread there actually requires the support from the policy and the regulation side to make, as you're trying to license objects to go into orbit, to ensure that there is a plan, that there is some kind of sustainability and method that they have in their disposal of their assets and where they're putting them and how they're avoiding interference with other operators. That is something that will become increasingly important to anyone that builds and operates a spacecraft, establishing those connections around the industry, the forums to exchange lessons learned and essentially, be able to coordinate against risk. So I think those two things are probably the key to achieving that, because the last thing I want to do is stifle the innovation that can occur.
Right. Are you optimistic?
Oh, yeah. Yes, I am very much so. I think, just in the changes in conversation that I've had over my career from, the very early days when people didn't really understand even what debris was, to the conversations we have now with fellow companies in the industry. It's a phenomenal increase in awareness and understanding, and everyone that we do interact and do speak to wants to do the right thing. So it's just a case of making sure that we enable that possibility.
That's great to hear. So, we're talking about the bigger picture, what the industry itself needs to do to have a more sustainable future in space. Any thoughts on the specific technologies that will enable sustainability?
So we actually think about that quite a lot. So one of the things that we focus on in Astroscale really is the enabling technologies for more of an on-orbit servicing or a logistics arm to the space environment. And the ones that we focus on internally are related to RPO, so rendezvous and proximity operations. So that's very much the algorithms and the operational approach to how you can go and service another vehicle, whether that is to go and dock to remove a piece of debris, or whether that is to go and help inspect another satellite because it's got a problem, or it needs to be moved from A to B, or any of the other kind of typical logistics activities. So the elements, the RPO, there's obviously a lot of good math in there, but we also look at the docking technology, so the physical method by which we can support and service another on-orbit asset. And then the third kind of wing to what we do really is the operations side of things. We're very much a company with a service mindset. So being able to make that as painless as possible for other satellite operators on orbit, and to put into play the appropriate amount of autonomy and efficiency to enable on-orbit servicing to become a more day-to-day thing, as it would be for, if we go back to the automobile analogy where you can take it to the garage and get someone to rotate your tires for you. We need to kind of think ahead as to how those logistical options can help us make more of the space environment.
We can all, I think, agree, as you were saying, you're getting there's a receptivity in the industry to all of this. So I think we can all agree that space debris needs to be handled, and we need to be responsible, and we need to think about how we contribute, we meaning, all the players out there, right? How we all contribute to the sustainability of space. When it comes to things like the cleanup, like things that kind of go beyond the independent responsibility, who should pay for it? How do we enforce this? How do we make sure that as a planet, as a global community, that we are all responsible, and that everyone is taking part, and that in some cases, who should step in and make sure that some of these things are handled?
Yeah, absolutely. And that the who should pay is probably the most common question we get at Astroscale. The legal framework right now is pretty clear that nation states hold the liability, and that goes back decades. as we move forward into a new era, I think as an industry, we need to learn some lessons from others, from the more terrestrial industries that have had to address this problem, such as oil and gas. I think we need to be open that it isn't somebody else's responsibility and we can't expect somebody else to pay. As an industry, we have to take responsibility. And as you know, as well as just as a taxpayer, we have to find a solution that isn't one yet, Jen. It's a topic, a hotly debated topic amongst ourselves in the company and also the wider industry. And it will definitely involve policy and regulation. So it's a conversation between industry and government.
Right. Thank you. And before we wrap up, I would love to know if you have any words of advice for innovators who might be interested specifically in a career of sustainability or working on, sustainability efforts on Earth, but would really like to contribute to the space economy.
We're hiring. Does that count? No, I think the same way as I want to see terrestrial technology brought into the space industry, that the innovation and the minds that came up with that terrestrial technology would be so valuable. We need to broaden our horizons a little in this industry. So yeah, I mean, if they have specific ideas or they want to reach out, then please contact us through our website. I'd love to have a conversation.
Fantastic. Thank you, Claire, for being with us today. We really appreciate all of your knowledge about this industry and sharing a vision of the future, sustainability in space. So thank you. Appreciate your time. All right, now it's time to hear from our Max Briggs about who our winners are. It's time to announce the top 3 companies from this year's NASA iTech 2021 Cycle 1 Forum. Over to you, Max.
Thanks, Jen. Before we announce the winners, I want to bring some attention to a NASA iTech first. Skylabs is our first ever high school participant, and we think they did an amazing job. I'd like to let Ramona Travis, the chief technologist at the Stennis Space Center, say a few words about their honorable mention showing.
Yes, we are so excited to have this team join us. As Max just shared, it's our first young group of high school students from the North Carolina School of Science and Mathematics, a company called Skylabs with their technology called EcoGel, which is a carbon aerogel that has a number of applications. We have discussed how important it is to instill and enhance that entrepreneurial spirit from a young age before people feel like they can't do it or somehow it just can't happen for them, while people are still able to think it's possible. And here's an example of a young team that is doing so while they're still just rising seniors in high school. So we send an honorable mention to the team of Skylabs. Congratulations.
Yay.
Thank you, Ramona. And nicely done, Skylab. Now, for the announcement of the winners, all the companies did great. It was a very tough judging situation, but at the end of the day, the decision had to be made, and that decision for the 3 winners of the Cycle 1 Forum go to Blue Space AI, Full Cycle Bioplastics, and United Aircraft Technologies. Very nicely done to all of you. And Robin, if you'd like to call them up to say a few words, please do so.
All right, Christine and Joel, if you'd like to go ahead and come up.
Physically marching up to the stage. Thank you so much. I've been part of other accelerators and other pitch events like this, but this crowd, not only the innovators, but the judges, and just the support we got from Tom, Jen, David, and Max and Robin were so great. I've really enjoyed this experience and so honored. I'm actually tearing. I don't know if you guys can see. For being able to be part of this crowd in itself is winning. And it really encourages us to continue to innovate and to march forward. Thank you so much.
Thank you. Dane and Delane, would you like to say a few words?
Hi, thank you all so much. It's been, again, an incredible opportunity to work with the NASA iTech team. A huge thank you to everyone who works so incredibly hard at Full Cycle. You know, they make my job easy by doing the hard science, and I just get to talk about how great it is. So, you know, our PHA is a commercially viable solution to the climate crisis, and we're happy to pitch it here. Anyone who's interested in investment, in tech integration, funded research, please feel free to contact me. My email is delane@fullcyclebioplastics.com, and we look forward to partnering and seeing what else comes of this NASA iTech engagement. So thank you all. It's been great.
Just to add on, what an amazing group of people and judges, and just awesome to even be in the room. Really appreciate it.
Congratulations. United, Abigail and Darian?
First and foremost, I want to thank all the people at NASA iTech that spent hours working with us, making sure that the entrepreneurs have the opportunity to succeed. I actually we watched NASA iTech for close to 2 years now, and it's finally like a dream finally come to reality that we are able to share this and be able to present our technology that we envision in modernizing the electrical wiring management as we know. And I would like to also echo, this is also my team has been wonderful with me, like again, making me look good and doing the hard work in the background. So thank you to my team for doing such a great job, and thank you for this great opportunity. I look forward to what comes next.
Darian?
I echo what Eva said, and I really am very excited to organize all of your wiring systems. That's what that's my passion. Thank you everyone for such a wonderful opportunity, and all the entrepreneurs did an amazing job.
Thank you so much, and congratulations to all three of you. Max, back to you.
Yes, thank you again, everybody, and congratulations. NASA iTech is a unique forum that brings together a lot of people from a lot of different backgrounds, and it's exciting to be able to engage with everybody. I do want to shamelessly plug the Entrepreneurial Engagement RFI that we have right now for all of the people that are out there saying, hey, this is great, but there's other stuff we can be doing. Please feel free to let NASA know what we can be doing in entrepreneurial engagement by responding to our RFI that's open on beta.sam.gov. You just search NASA Entrepreneurial Engagement, you will find it. We are really looking to try to maximize how to improve outcomes for all of the entrepreneurs that come to us through mechanisms like iTech and others across the agency. It's really been a pleasure to work with all of you, and I appreciate each and every one of you. Thank you, and thanks to everybody tuning in online.